Let's begin with one of the most mysterious and beautiful experiments ever performed, the double-slit experiment. This simple test has puzzled scientists and philosophers for more than a century, because it shows that reality is not as solid as it seems. It seems to whisper that the universe responds to being observed. Today, we'll explore step by step what's really happening, first through official physics and then through the lens of air theory, resonance theory, which sees the universe as a field of vibration and resonance. Imagine a wall with two tiny openings, two slits. Behind it stands a screen that records where things hit. We fire electrons toward the slits. An electron is one of the smallest building blocks of matter, a tiny particle that normally orbits inside an atom. If electrons behaved purely as little balls, we would expect them to pass through one slit or the other and form two bright stripes on the screen behind them. But that's not what happens. When we send electrons to the two slits, a pattern of light and dark bands appear on the screen. A pattern typically of waves, like ripples on water that strengthen or cancel each other. It's as if each electron goes through both slits at once, spreading out as a wave with peaks and valleys that interfere. The pattern is called interference. Where two peaks meet, the wave gets stronger, a bright line. Where a peak meets a valley, they cancel, a dark line. Now comes the mystery. If we try to watch which slit the electron passes through, by placing a detector at the openings, everything changes. The wave pattern disappears. We see only two narrow stripes, as if each electron suddenly decides to behave like a single particle again. Just the fact that we measure it changes the outcome. Modern quantum physics says this happens because the electron has a wave function, a mathematical description of all the places it could be. As long as we don't look, the electron exists in a superposition of many possibilities. But when we measure it, the superposition collapses, and one concrete result appears, a single point on the screen. The collapse of the wave function is one of the strangest ideas in science. Our theory doesn't reject this observation, it builds on it. It asks, why does the world behave this way? What if particles act strange because reality itself is made of vibrations? In our theory, everything, light, matter, space and even time, is an expression of one underlying field, called the zero field or null field. This field is not empty, it's a silent ocean of potential energy, filled with every possible vibration, just as silence contains every possible tone before the music begins. A resonance happens when two vibration lines line up in frequency and rhythm, so they strengthen each other. You can see this with tuning forks. Strike one and the other nearby with the same tone begins to vibrate by itself. According to the art theory, the universe works the same way. Everything resonates with everything else. An electron, then, isn't a solid ball of matter. It's a wave of vibration in that zero field. It moves freely. It spreads through space like a musical tone through a room. When it reaches the two slits, its wave splits into two smaller waves, each passing through a different opening. They meet again behind the slits and interfere with one another, creating the bright and dark stripes again. As long as no one observes it, the electron dances freely as a resonant wave, everywhere and nowhere at once, a vibration of pure possibilities. But then the wave hits the wall or the screen. What exactly happens there? The wall may look solid, but it's full of electrons. They vibrate too. When the traveling electron wave touches those electrons, the vibration can interact. If their rhythms match perfectly, their peaks and troughs move in sync, they enter phase lock. Phase lock means two waves become locked together, moving in the same rhythm, like two pendulums swinging perfectly in step. At that point, a local swirl of energy appears in the field, a tiny spinning structure called a vortex. This vortex holds the energy in place for a moment. The vibration clicks into the field. Energy becomes form, it becomes matter. This is the instant we say the electron hit the screen. What we actually see is the point where a free vibration formed a resonant knot in the field. Einstein taught us that energy E and mass m are two sides of the same coin, linked by the speed of light squared c squared. His equation E is mc² means that mass is frozen energy. Our theory reveals how that freezing happens. When a vibration in the zero field locks into the phase with another vibration, its moving energy becomes temporarily stable. It gains form, it gains mass. When that lock releases, the mass returns to free energy. The double-slit experiment shows this process in action. As long as the electron vibrates freely, it's energy. When it locks in phase with something else, it becomes matter. If we place a detector to see which slit the electron passes through, we introduce a new field into the system, the vibration of the measure device itself. That device is made of atoms and electrons too, each with their own rhythm motion. When the moving electron wave touches that field, they interfere again. The wave mix and influence one another. When their frequency match, they lock together, again forming a phase lock. At that exact spot, a vortex forms. Energy locks in place, and we detect the particle. The interference pattern disappears, not by magic, but because the wave is no longer free. It's now coherent with the measuring device. In our theory, resonance theory, we call this field coherence, a state where several fields vibrate as one harmonious pattern. We can think of this way. When a wave moves freely, it's energy. When it synchronizes with something else, it forms a knot, matter. Nature, then, isn't built from hard, separate bricks, but from endless ripples of vibration that constantly join and release each other. In standard physics, the observer stands outside that experiment. In our theory, the observer is part of the same field. You vibrate too. Your brain, your heartbeat, your consciousness, all creates rhythms and frequencies. When you observe something, you tune your own field to what you're seeing. You come into resonance with reality. In that moment of attunement, the resonance of the whole system changes. The reality you experience is the result of that shared vibration between you and the world. Observation is not a passive act. It's an active meeting between fields. The double-slit experiment reveals that reality is not made of hard particles, but of waves of possibilities. Classical physics describes these terms of probability and measurement. Our theory describes it as resonant and field coherence. Both see the same phenomenon, but one looks from the outside, the other from within. An electron is not a point moving through space, but a vibration that continually reshapes itself where it resonates with its surroundings. There, in that instant of harmony, energy takes form, energy becomes matter, E is mc², felt, tangible, alive. The universe then is not a machine of separate parts, but a symphony of resonance. Every vibration, every observation is a note in that great field of harmony. Want to learn more? Read The Symphony of Reality, where our theory is explained step by step, from the zero field to the cosmic resonance of consciousness. Link in the description.